Hello and welcome to Chapter 4, Section 2. Today we're going to talk about transversals and parallel lines. A transversal is a line that crosses two coplanar lines. Here I have line P and line Q, and transversal T that crosses them. And when a transversal crosses a line, it makes four different angles. Now it makes two sets of two vertical angles as well. 1 equals 3, 2 equals 4, 5 equals 7, 6 equals 8. And if the lines are not parallel, if P and Q are not parallel, that's all you have. So we have a little bit of vocabulary that we're going to use throughout. Corresponding angles are the same sides of the line. So we're saying some of these correspond to some of these. Corresponding angles mean the same side of the line and the same side of the transversal. So that here, the same side of the line, let's pick underneath it, and the same side of the transversal would be this side. So 3 and 7 are corresponding angles. So if we said above, both were above and both were on this side, then angle 1 and angle 5 would be corresponding angles. So wherever it sits in these four, it also sits the same spot in these four. Same side interior angles, which means the same side of the transversal, but between the lines. Interior means on the inside, so they're going to be interior, but on the same side of the transversal. So 3 and 6 are same side interior angles. 4 and 5 are same side interior angles. 1 and 2 are not interior. 7 and 8 are not interior. So, and then we have alternate interior angles. So again, we have to be interior, but they're on either side. So 3 and 5 are alternate interior, not same side interior, but alternate. And 6 and 4 are alternate interior angles. So between the lines, but opposite sides of the transversal. Then we have alternate exterior angles, which means they're on the top or the bottom, and they're not on the same side as of the transversal. So 8 and 2 are alternate exterior, and 1 and 7 are alternate exterior. So please, when you're looking at these, you're keeping track of same side or alternate, and interior or exterior, okay? We have a same side interior angle postulate, and we will refer to this a lot. And we're gonna shorten it to the same side interior angle postulate when we write about it in our proofs. If two lines are parallel, and by putting these little arrows here, we say that they're parallel. This is the shorthand diagram version. And they are cut by a transversal, then the pairs of same side interior angles are supplementary. This angle and this angle, same side interior, or this angle and this angle are same side interior, which means angle 4 is supplementary to angle 5, and angle 3 is supplementary to angle 6. Now we have to prove it. So we know that 1 and 4 are linear angles. And because they're linear angles, they are supplementary, because that's the definition of supplementary, is that they form a line. Because P is parallel to Q, all the angle measurements are congruent. All of these angle measurements are congruent to all of these angle measurements. So angle 1 is congruent to angle 5. Measure of angle 1 is congruent to angle 3 because of vertical angles, and 2 is congruent to 4 because of vertical angles. 4 and 5 are supplementary because of the same side interior angle postulate, which means 1 and angle 5 are both congruent because both are supplementary to angle 4. and 5 is congruent to angle 7 because they are vertical angles, and 8 and 6 are vertical angles, and 5 is supplementary to 6 because they are linear. So you can go round and round with these and continue to talk about how they're related. Next, we're going to talk about alternate interior angles being congruent. The alternate interior angles theorem, which is AIAT, says that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles have the same measure. So what I'm saying is 5 and 3 are the same measure. 4 and 6 are the same measure. So let's prove that. We're looking at angle 4 being congruent to 6 and 5 being congruent to 3. So we know that P is parallel to Q. That was given. And we know that 3 and 6 are supplementary because of same side interior angle postulate. We know that angle 3 plus angle 6 equals 180 because that's the definition of supplementary. We know that angle 5 and angle 6 are a linear pair. That's given in the diagram. And that makes them supplementary because of the linear pair theorem. So that means that the angle 5 plus angle 6 is going to equal 180 degrees. That's the definition of supplementary. So if measure of angle 3 plus the measure of angle 6 equals measure of angle 5 plus the measure of angle 6, because of the substitution property of equality. So we're saying 3 plus 6 is the same as 5 plus 6. We just proved 3 and we just proved 5 here, which means that angle 3 must equal angle 5 because of subtraction property, or what's it called? Transient. So there are a lot of different ways of going about this, but I need you to understand all the connections. So do the reflection questions, numbers 3 and 4. Pause here and come back when you're done. With number 3, we know that 1 equals 3 and 5 equals 7 because they're vertical angles. And that means that 3 equals 5 because alternative interior angle theorem. So 1 equals 3 equals 5 equals 7 because of the transitive property. A, measure of angle 6 is 57 because of the alternate interior angle theory. Measure part B, we know that 5 and 6 are supplementary because they make a linear pair. 4 and 5 are also supplementary because of same side interior angle postulate, which means that 180 minus 5 is 4. It's also 6. So it's all the same. Next thing we're going to do is prove that corresponding angles are congruent. Now remember that corresponding angles means whatever spot it is on this part, it is the same spot on that part. So the corresponding angles theorem, which is CAT, says that if two parallel lines are cut by a transversal, then the pair of corresponding angles have the same measure. So if we know these are parallel, then with one transversal, all 4 of these angles are going to be congruent to all 4 of these angles. So we know that 1 and 3 are the same because of vertical angles, and 5 or 7 are the same because of vertical angles. But what they're saying is because 1 is also equal to 5 and 3 is also equal to 7, which means they're all equal to each other. And the same goes for 2, 4, 6, and 8. So pause here, try the reflection questions, numbers 5 and 6, and come back when you're done. So for number 5, the measure of angle 4 plus the measure of 5 equals 180 because of the same side interior angle postulate. And if I add 1 and 4 together, it's going to give me 180 degrees, and that's what a linear pair is. Therefore, this is how you say therefore in shorthand geometry speak. 4 plus 1 is the same as 4 plus 5, which means 1 equals 5. That's the transient property. And with number 6, 4 plus 5 is 180, and 180 minus 36 is going to give us a total of 144 left over. Next part, using parallel lines to find angle pair relationships. So now we're going to take all of the stuff that we've learned and we're going to apply it to real life. So I'd like you to look at B, at your turn 7, and then at elaborate 8, 9, and 10. With B, it's the corresponding angles theorem, and we're going to stick in angle WUV there, and 180, and x equals 5, which means that final answer is 135 degrees. With number 7, we have a picture that looks kind of like this, and we know that this angle here and this angle here are the same. So we can say 3x plus 2y equals 36. We also know that this angle and this angle are the same, so we can say 12x plus 2y equals 126. What we want to do is solve for y on one of them and then stick that into the other equation so that we can solve for x. So here what I've done is I'm solving for y. I subtract 12x from both sides and then divide by 2. So y equals 63 minus 6x. I'm going to take this and substitute it for y here. 3x plus 2 times that equals 36. So I've distributed my 2. And I've combined 3x and negative 12y and subtracted 126 from both sides, and I get negative 9x equals negative 90, so x equals 10. And when I stick x equals 10 back into this equation, y equals 3. Elaborate. Number 8, the postulate shows that pairs are supplementary, while theorems show that pairs are equal. Number 9 is yes. The measures of angles 1, 3, 5, and 7 all equal to each other. 180 minus measure 1 equals 2, 4, 6, and 8. They're all the same number. And number 10, you need the same side interior angle postulate to connect the two sets of measures. Your homework for this section is numbers 1 through 23 all. Please let me know if you have any questions. Thank you much.